All right. So we are at number 24. They're saying that every kilogram of water requires 340 kilojoules to be removed from it to turn it into ice. Therefore, if you have 10 kilograms of water, you should have 10 times 340 kilojoules, right? Which would be 3,400 kilojoules of heat to be given out, not absorbed, right? Because we are going from water to ice, not water to steam. All right, so D is your answer. All right, 25. In the theory coming up, amplitude is determines the loudness. Now, the first thing you have to understand is that the displacement time graph shows the displacement of a single particle as time progresses. All right. So the height of the crest or the depth of the trough will give an indication of the amplitude. All right. And the pitch is determined by the frequency, which you can evaluate from the number of waves that you see in a certain amount of time. All right, if you look at the number of crests or the number of troughs, so basically in P, you have 3 crests in the same time as Q, where you only have 2. Therefore, the frequency of P is higher than the frequency of Q. However, the amplitude of Q is higher than the amplitude of P. So we are able to say that the loudness of Q is higher, but its frequency is lower. So which one of them matches that? Q is louder, but P has a higher pitch. So that's C. (26). This is a displacement position graph. And for a displacement position graph, we cannot extract any time-related information because it's showing the position of all the particles at an instant in time. All right. So it's showing where all of the particles are at a fixed point in time. Time is frozen in the displacement position graph. Therefore, we cannot extract any time-related information from this. And therefore, the frequency is unknown. So we have D as our answer. Number 27. All right, so the image of the flower is the same distance behind the mirror as it is in front. And therefore, we have the object, which is the flower, is at 7.5 meters away from the mirror. If you subtract this 0.5 from the 8, you get 7.5. So 7.5 here. So that means behind the mirror, 7.5. plus 7.5, that's 15, and then 0.5, so the girl is 15.5 meters away from the image. All right, 15.5 answer is D. 28, an object is placed at the bottom of a tank of water and viewed directly from above, which of the following be true of the image. All right, so when light rays move from more dense, optically denser medium to an optically less dense medium, the rays will be refracted and therefore produced in a virtual image, because once the rays are refracted to your eyes, the image will appear to be at a different position than the object. And so your eyes interpret a virtual image. It will not be diminished, it will be the same size, but it will be appearing closer to your eye, sorry. Therefore, 1 and 3 are true, and therefore your answer should be C. 29. So what causes the spectrum? All right, we know, well, two things that we can look at. Red has a longer wavelength, right, than violet. And we also know that the shorter the wavelength, the more refraction that is obtained. All right, so you can eliminate if you are not sure. Color violet has a shorter wavelength and refracts more than the color red. And that is true. The color red has a longer wavelength and refracts less than the violet. That's also true. And 3 and 4 so 3 and 4 are false. 1 and 2 correct. Answer is A. Number 30. So this one is showing a right angle triangular prism, telling critical angle of glass is 42 degrees. X is a ray of light perpendicular to the surface BC. So if we use our geometric understanding, we'll see that when X projects onto the side AC, it will be at an angle of 45 degrees to the normal, and 45 is greater than 42. So you will have total internal reflection. So X will not emerge from the glass here, but it will be reflected. So it will be P. All right. It will not come out of the glass from the side AC because it is totally internally reflected. So P is the answer. All right. So I'm going to ask Miss Rose to continue.
Okay, good evening, everybody. So we'll move on to item number 31.
Miss Rose, you have your document open.
Okay, let me open it.
All right, let me just skip to 31 here. In the meantime.
Let me see if I can do this thing here. Can you guys see my screen?
Yes, miss.
All right. So number 31 says, which of the following waves requires a medium of transmission? No, radio waves, infrared waves, and light waves are types of electromagnetic waves, and these waves can actually travel through a vacuum, which means that they do not require a medium. However, sound waves require a medium in which to travel. So our answer is D. Number 32, the refractive index of a transparent medium with critical angle C for light traveling from that medium to air is now refractive index. If it's traveling from air into a particular medium, we use the equation sine I over sine R, and I and R are the angles of incidence and refraction respectively. Now at the critical angle, which is C, the angle of refraction is going to be 90 degrees. Now, since the light is traveling in the opposite direction, if we want to find the critical angle, we'd have to invert the equation used previously. So we'd end up with n being equal to sine R over sine I. And we know that R is going to be 90 degrees. So it would be sine 90 over sine C, because C is the critical angle, and that is the angle of incidence, which will give an angle of refraction of 90 degrees. So our answer is C. All right, number 33. A piece of paper was burnt by adjusting the height of a converging lens above the paper until the most concentrated beam of sunlight was obtained. The distance between the lens and the paper was 10 centimeters, and the question asks us what is the focal length in centimeters of that particular lens. Now, a lens that is used in this way, a converging lens, one can often or easily think of a magnifying glass. Now, in order to find the focal length, all we need to know is to note the distance that the lens is from the paper that is being burnt. So if the distance between the lens and the paper was 10 centimeters, it means that the focal length of the magnifying glass or the lens is also 10 centimeters. All right. I'm not seeing 33. Let me. Are you guys seeing number 33? No?
We were seeing it.
Oh, okay. So let me share again. All right, everybody seeing it?
Yes, miss.
All right, so our answer is B. All right. Brings us to number 34, or through an aperture or a hole. Now, if you look at number 1, then you don't really see any spreading out of the waves occurring there. So that would eliminate A and C. For number 2, you can actually see where the waves are spreading as they go through the aperture there. So it means that our answer would have to be B. All right. There is no spread in number 3, you can actually see where it seems that the wave fronts are actually getting closer to each other. In diffraction, there is no change in the wavelength. So 3 would be out as well. So it's just B, 2, which is B. All right. Now the diagram shows a transverse wave that is at a particular instant in time. So it's a displacement position graph. So the question asks us to determine which length would give us the wavelength. Now, from P to Q, you would see that the particles, they are actually not at the same position in terms of their motion, or they're not in phase with each other. Neither are they at P to R. Where from P to S, you could see that both of them are actually in phase, and that's the definition of a wavelength. The two particles that we are concerned with, they must be in the same phase of the motion and traveling in the same direction. So our answer would be PS, which is C. Right. Number 36 shows a light ray that is incident at the air glass interface at an angle of incidence of 50 degrees. Now the critical angle for glass is 45 degrees. So once again, because the light is traveling from a more optically dense medium to a less optically dense medium, we know that the light ray is going to be bent away from the normal. And since that critical angle is 45 degrees and the angle of incidence is greater than the critical angle, then we will have total internal reflection taking place. So that's A. For number 37, which of the following statements is true of a diverging lens? Another name for diverging lens is the concave lens, and that lens is thinner at the center than at the edges. Diverging lenses will always produce virtual images, so C would be out, and virtual images are always upright, which means B would also be out. Now, diverging lenses produce diminished or smaller images, so D would also be out. So our answer is A. Now for 38, what is the equivalent resistance of the two resistors shown in the diagram? Now, if you look closely, you will see that R1 and R2 are connected in parallel with each other. They don't share the same path in terms of the current flow. Now, in order to calculate the effective resistance of resistors that are in parallel, we use the relationship that 1 over the total resistance or effective resistance is equal to 1 over R1 plus 1 over R2, and we can go on to infinity. So that would give us over sum rule. So that would be 2 times 4, which is 8, divided by 2 plus 4, which is 6, and 8 divided by 6 is 1.3. Now that rule only works when you have 2 resistors in parallel. It won't work if you have 3 or more. So just note that. All right. A current I flows for a time t between 2 points at a potential difference of V. The power expended is equal to, now we know that power is equal to voltage times current. So we would select C for our answer. Now remember that current already has time in its, in terms of the quantity, because the current has to do with how much charge is passing in a given time. All right, so our answer for 39 is C. Number 40, a glass rod is rubbed with a piece of silk and it becomes positively charged. The glass rod became charged by, now objects become charged when they either gain or lose electrons. Now the protons are fixed within the nucleus, so they don't move very easily. So by rubbing, you can transfer electrons between objects. Now, because electrons are negatively charged, if a glass rod or if any object becomes positively charged, it means that it would have had to lose electrons, so it now becomes overall positive. So that's B. Number 41. Which of the following diagrams represents the electric field existing between two oppositely charged point charges? Now, by convention, the direction of an electric field is always shown going away from the positive and towards the negative. So that would leave us with A for answer. Now for point charges, the field always, it goes around and not straight across, as is shown in D and C. So our answer there would be A, going outwards from the positive and towards the negative. Okay. Number 42, we have a diagram here that shows an electrical circuit with two filament bulbs and a cell. Now, if you look at the diagram, you realize that there is only one path through which the current flows, which means that this is a series circuit. So if you were to draw an equivalent circuit to that circuit above, then it would have to be C, where the two filament bulbs are actually alongside each other with just a single path of current. Number 43, the resistance of an ideal ammeter is assumed to be 0. Now, an ammeter, we want that to have 0 resistance, ideally, because we are measuring the current. So if we have low resistance or the lowest resistance that is possible, it's not going to affect the amount of current that flows within the circuit. Right? So that means our answer is A. Number 44. Which of the following is not one of the ways in which the strength of the magnetic field near a solenoid which carries a current can be increased? Now, you can increase the magnetic field strength of a solenoid by increasing the current, increasing the number of turns of the coil, or you can place the soft iron core inside the coil. So it's asking which of the following is ways that you could not increase the magnetic field strength. So B, C, and D would be out. So it means that A is the answer. If you increase the resistance of the coil, you're actually decreasing the amount of current that flows. So that would actually decrease the strength of the magnetic field. Which of the following concerning voltmeters is correct? Now, a voltmeter is always connected in parallel to the component. So C and D would be out. And ideally, the resistance of a voltmeter should be very high so that it does not take away from the current that is actually flowing within the circuit. So our answer is B. All right, so we're now at number 46. Which of the following diagrams represents the current potential difference relationship for a metallic conductor at constant temperature? Now, a metallic conductor is one of the devices that we call an ohmic device because it obeys Ohm's law at constant temperature. Now, Ohm's law says that for constant temperature, the current that flows within a circuit is directly proportional to the voltage. So the graph that shows that is B. All right, so it's a straight line through the origin. That's B. At number 47, an ideal transformer has 1,200 turns on its primary coil and 600 turns on its secondary coil. If the voltage across the primary coil is 20 volts, the secondary voltage is dash. Now, an ideal transformer will obey what we call the turns ratio, and that turns ratio actually shows that the number of turns in the coils is equal to the voltage across either the primary or the secondary coil. So it would be the number of turns in the primary divided by the number of turns in the secondary is equal to the voltage in the primary divided by the voltage in the secondary. So if we use that relationship, we can solve for the secondary voltage and we would get 10 volts. Answer is C. Right. Now the following diagram shows a cell E, a diode P, and a resistor R, which are connected in series. Which of the following graphs best illustrates the current that is flowing through R? Now, based on the diagram, the current that is flowing is direct current. The diode is placed in forward bias in the circuit, so it means that the current is going to flow as normal. Once the diode is placed in forward bias, then current flows as normal. If it is turned in the opposite direction and it's in reverse bias, then it will act like a switch in the off position. So since we have direct current flowing, then our answer is going to be C. So a cell produces steady direct current. Which of the following statements about alternating current is true? Now, based on what we know about alternating current, we know that transformers actually alter the voltage of the current and not necessarily change it to direct current. Now, we recharge batteries using DC, not AC, and we use AC for transmission of electrical energy because it can be produced at high voltages and not necessarily because of the frequency at which it travels. Now, we also know that rectification can occur, whether it be half wave or full wave rectification. We can do that with alternating current using a semiconductor diode. So our answer is B. Right. Which of the following statements about insulators is not true? Now, in an insulator, one common thing about insulators is that the electrons are tightly bound within the structure. It is the electrons that are responsible for transmitting or for carrying current. So it is because of this that insulators actually don't conduct current very well because they do not have any free electrons. So our answer is B, because this statement says that electrons can move freely from atom to atom. So that statement would be untrue. All right, item 51 refers to the diagram. An iron rod PQ is placed in a plastic pipe wound with a coil as shown in the diagram, and a current passes through that setup. So when the current is switched off, the rod is likely to, and we have our choices there. Now, this setup actually creates a magnetic field within the iron rod PQ. Once the current starts to flow, it generates a magnetic field. And based on the manner in which the current was flowing previously, if you look at the diagram, you can see where the current flows anti-clockwise from P, which means that you would actually have a north pole at P and a south pole at Q. So our answer is C. All right. Number 52, an electromagnet consists of insulated wire wrapped around an iron core. Now, the foundation of electromagnetism is that whenever we have an iron core, it becomes magnetized because the magnetic field is produced by the current. So a magnetic field is actually produced inside the coil when the current is turned on. So our answer is C. All right, number 53. The electric power that is supplied to homes and factories is alternating current rather than direct current because, and we had discussed some of these previously, but basically we use alternating current mainly because it reduces transmission losses. So based on the power loss formula, I squared R, we can use that to show that AC actually reduces the loss of power from those lines. So we can transmit high voltage and low current, and it's also safer. So our answer is B. Okay, number 54. Which of the following would be possible symbols for an isotope of a nuclide represented by X with superscript A and subscript Z? Now, isotopes are atoms that are of the same element that have the same number of protons. Now, the number of protons or the number of electrons is given by the subscript, which is Z. So it means that an isotope would have to have the same number. So that would leave us with D. So our answer is D. Right. Now the nuclide, I think that's thorium. It has a mass number of 234 and a proton number of 90. As said before, the bottom number tells us the number of protons. And now to calculate the number of neutrons, we subtract the proton number from the nucleon number. So it's 90 from 234, and that would give us 144. So it would have 90 protons and 144 neutrons. So our answer is supposed to be C. All right, so that's supposed to be C, not B. All right, so alpha particles, beta particles, and gamma rays from a radioactive source are subjected to a transverse magnetic field. Now, based on what we know about the alpha, beta, and gamma rays, we know that gamma rays, because of their very small mass, they are undeviated in both electric and magnetic fields. All right, so our answer is B. All right, a radioactive isotope has a half-life of 20 days. How many days will it take for a given sample to have its activity reduced to 1/8 of its original or initial value? The half-life being 20 days simply means that every 20 days, the number of particles that remains will decrease by half. So if it starts off with one whole, after 20 days, you would have half. Then after 20 more days, you would have a quarter. And after 20 more days, which would be 60 days in total, you would have 1/8 remaining. So our answer is B, 60 days. Right? Which of the following describes two properties of an alpha particle? Now, alpha particles are analogous or similar to helium nuclei, which means that they have positive charges. So A is out and C is out. Now, alpha particles actually do not have very high penetrating power, so that would leave us with D. The answer is D. Okay. Sodium 24 decays into magnesium 24 with the emission of a beta particle, and it can be represented by the equation. Which of the following should be placed in the box to complete the equation? Now, based on any chemical equations, we have to make sure that we conserve mass. So looking at the formula or the equation that is shown, we need to use a species that will give us 24 at the end, and we need a number that when we add it to 12, we get 11, and that is -1. So our answer is A. And that's also the symbol that we use for beta particles. All right. No radioactive nuclei are present in this sample at time equals 0. Which of the graphs best represents the variation of with time of the number of undecayed nuclei present? Now, the relationship between the activity of a substance and the time that has elapsed, it shows an exponential decay. So you'd expect to get a curve, and it's a downward curve. So you would select D, as in dog. All right, so I'll hand back over to Mr. Campbell for the remainder of the time.
All right, thanks, Miss Rose. And thank you everyone for joining. Please remember to check out our website, onlinesciencetutor.net. All right, all the best.
Thank you, sir.
All right, guys.
All right.